Hello students, how are you all? I hope you all are fine. Today we'll see Standard 6 subject Science. In that chapter number 13. Chapter name is Fun with Magnets. Today we'll see part 3. In the previous video we have seen part 2. In the previous video we have seen up to main 6. Today we'll see main 7. Explain giving scientific reasons. It carries 2 marks each. Number 1. Repulsion is the sure taste for magnetisms, or the question can be asked in another way, is the real taste of magnetism is not attraction but repulsion. Answer is attraction take place between the opposite poles of two magnets as well as a magnet and a piece of iron. So, we cannot clearly identify whether a given slab is iron or is it a magnet. Whereas repulsion takes place between the opposite poles of magnets only. So, if two objects repel each other, we can quite confidently conclude that both the objects are magnets. A metal piece does not repel a magnet. See the question number 2. A magnetic needle is used in a magnetic compass used to know the direction. Answer is the small needle is pivoted on a vertical axis in such a manner that it can rotate freely in the horizontal plane. Hence, when at rest, the north pole of the needle points towards geographic north and the south pole of the needle points towards geographic south. Hence, a magnetic compass used to know the direction. See the main aid. Give 2 points of differences. 2 marks each. Difference between natural magnets and artificial magnet. Point 1. It is made up of stone or a piece of rock. And point 1, in artificial magnet, it is made up from iron, steel or alloys using a magnet. Point 2. It has irregular shape, and here it has a regular shape. Now we will see the next page. See the main 9. Classify the following into materials that are attracted by magnet and materials that are not attracted by magnet. 4 marks. First of all, we will see the materials given: sand, ball pen, key, matchstick, copper vessel, nickel vessel, glass, iron, aluminium, pin, cobalt metal, stainless steel, nail, stone and needle. Magnetic materials are nickel vessel, iron, pin, cobalt metal, stainless steel, nail and needle are the magnetic materials, and non-magnetic materials are sand, ball pen, matchstick, copper vessel, glass, aluminium, stone are the non-magnetic materials. Now we will see the main 10. Answer the following questions in details. 4 or 5 marks each. Number 1. Draw the figure of a magnetic compass and explain its constructions and working. See, here the figure of a magnetic compass is there. See, the north direction, south direction, east and a west. Here is the cylindrical case and is the circular dial, and here in the middle it's a magnetic needle. Construction. A magnetic compass is a small cylindrical box made up of either aluminium or brass. There is a circular disc marked with a direction. A magnetic needle is pivoted on a vertical axis in such a manner that it can rotate freely in the horizontal plane. The case is covered by glass cover. Working. The magnetic compass is rotated in the horizontal plane in such a manner that the north pole of the needle comes on the letter N marked in the compass. Now the directions shown by the compass are the true direction. See the question number 2. Describe an experiment to show that unlike poles of a magnet attract each other and like poles repel each other. Also draw the necessary figure. Aim is to show that unlike poles of a magnet attract each other and like poles repel each other. Apparatus and materials: 2 bar magnet, wooden stand, thin strong thread. See the next page. See the figure. See, here it's the north south pole and it's the north pole, and here magnet. If south is there, then it's rotate. Okay, see, then comes north, and north in this direction. Here north north, so it's again rotate. Effect of unlike poles of a magnet, effect of like poles of the magnet. Like means north north, and unlike poles means south and north. That's the unlike poles. Now see procedure. Take a bar magnet, tie it with a thread and suspended it from a wooden stand in such a manner that it can rotate freely in the horizontal plane. Take another bar magnet, bring the south pole means S of the bar magnet held in the hand near the north pole of the suspended magnet. In the same manner, bring the north pole of the bar magnet held in the hand near the south pole of the suspended magnet. Observe what happens in both the cases. Now bring north pole of another magnet near the north pole of the suspended magnet. In the same manner, bring the south pole S of the other magnet near the south pole of the suspended magnet. Observe what happens and note down your observation in a table. See here the observation table is there. Poles of the suspended bar magnet and poles of the bar magnet held in the hand and result. See the first one, north pole, and here in the hand south pole. Then attraction. See south pole and north pole attraction. North pole and north pole then repulsion. South pole and south pole then also repulsion. See the conclusion. Conclusion is the unlike poles means north south and south to north of magnets attract each other, whereas the like poles mean north north and south south repel each other. Question number 3. You are given an iron strip. How will you make it into a magnet? Answer is: take a rectangular iron strip, take a bar magnet and keep it in contact with one of its poles with one edge of the iron strip. Without lifting the bar magnet, move it along the length of the iron strip till you reach the other end. Lift the magnet and bring the same pole you started with, to the same point of the iron strip from which you began. Move the magnet again along the iron bar in the same direction as you did before. Repeat this process about 30 to 40 times. Bring few all pins near to the iron bar. It will behave as a magnet. Now see the activities. To know the positions of a poles in a magnet, here apparatus and materials are a bar magnet, iron fillings and paper. Procedure: spread some iron fillings on a sheet of paper. Now place a bar magnet on this sheet. Slowly move the bar magnet on the paper. Lift the bar magnet gently away from the paper. Observe the pattern in which the iron fillings get attracted by different parts of the magnet. Remove the iron filling sticking to the magnet and repeat the experiment. Note down your observation. Observation is: maximum iron filling stick to the ends of the magnet. As you move towards the center of the magnet, the amount of iron filling stuck to the magnet goes on decreasing. Conclusion is that in a magnet, the magnetic strength is more near the ends. These ends are called the poles of a magnet. See the number 2. To demonstrate that a bar magnet free to rotate in the horizontal plane always comes to rest in north-south direction. Apparatus and materials are bar magnet, wooden stand, thread. Here the bar magnet is there, north-south direction is the thread and wooden stand. Procedure: take a bar magnet, put a mark on one of its ends for identification. Point 3. Tie a thread at the middle of the magnet so that you may suspend it from a wooden stand this way, in such a manner that the magnet can rotate freely in the horizontal plane. Number 4. Let it come to rest. Mark 2 points on the ground to show the position of the ends of the magnet when it comes to rest. Point 5. Draw a line joining the 2 points. It shows the direction in which the magnet was pointing in its position of rest. Point 6. Now Rotate the magnet by gently pushing one end in any direction and let it come to rest. Again, mark the position of the two ends in its position of rest. Observation: the magnet always comes to rest in the same direction. This is the north-south direction. And conclusion is that a bar magnet free to rotate in the horizontal plane always comes to rest in north-south direction. Here your chapter is completed, and we will see the next chapter, chapter number 14, in the next two videos. Stay safe, stay healthy. Okay, bye.